How are you today?
I'm doing fine.
Good. So I just had a session with a girl who got this from Jansek's honors class.
I've already done that.
I was just going to say, since you said you didn't have any homework, I'm sure you've done all of these. And there were 2 pages. Did you have any troubles or questions about any of it?
No, not really.
Pretty basic stuff.
We had the practice final. We had a practice final on Wednesday about what I'm doing tomorrow. It was only 50 questions, not 75, but I got a 48 out of 50.
Oh, wonderful. Wonderful.
So if that transfers over, then I'll get a 70. If I go at the same rate, I'll get a 72 out of 75.
I kind of figured as I was going through these, I was a little surprised with how easy they were. Yeah, none of these present any difficulties at all, except for maybe number 3. Number 3 is a little bit unusual. Did you have any problems with number 3? Do you want me to explain that at all?
Okay, I think I already understand how to do that. You find the slope.
No.
Then you find the distance.
I'll give you an easier way to do it. It really is a really easy way to do it. If you graph the 2 points, that's -1, -2. Excuse me, that's 1, yeah, -1, -2. That's the midpoint. And if you graph the end of another point, which is 4, 4, well, if I draw the line, then this is the point they want, right?
Yeah.
Now, what we know about midpoints is that the x-coordinate is halfway in between the 2 x-coordinates and the y-coordinate is halfway in between the 2 y-coordinates, correct?
Yeah. So you just find the difference between...
How far away is -1 from 4?
5. So the x-coordinate for v would be -6.
Yeah, in other words, I got to go 5 units in the same direction, which is a negative.
The y-coordinates. Then the y-coordinates are 6 apart, so therefore the y-coordinate for v would be -8.
Okay, you understand that perfect. Fine.
So D. The answer is D.
Yeah. All right. I'm not going to find one on here that's even worth talking about with you because even number.
The only reason I didn't get all of them correct is because we had a midsegment of a trapezoid problem. Yeah. And I got the length of the midsegment, but the length of the midsegment was h plus 9. The length of the midsegment was 38, and I forgot to subtract 9.
Oh, yeah. Okay. Okay.
And get 27 for h, so I lost a point there. Okay. And then the second one was about translations and crap.
Okay. It can help you.
So what I learned from that is I
help you a lot with translations.
No, the translations aren't hard. What I really need to remember is the y equals x and x equals y lines. It's just what I did for that translation thing was I was being close-minded and not checking all possible answers because it was multiple answers that were correct, and I only took one.
I do want to show you this particularly hard one that you probably got from Jansek a week ago or so. Hold on a second. Let me bring it up. Let's talk about it for just a second because you'll enjoy it. Difficult geometry problems that you can solve are very enjoyable. It's nice to put in effort on a problem that is not easy. And geometry comes in all flavors. Don't
I get that.
Did you get this one?
Nope.
Did you get it as a problem? I mean, did he give it to you?
No, he did not.
Did not give this one to you. Okay. Well, I'm going to look at it for a few seconds. Basically, we're looking at a tetrahedron, and this thing in the middle is...
You're trying to prove it's a rhombus, right?
Well, it doesn't tell you what it is, but yeah, you're trying to figure out what it is and then prove it using a two-column proof. But E is the midpoint of JL, F is the midpoint of KL, G is the midpoint of KM, and H is the midpoint of JM. And the only other information they give you is that JK is equal to LM. And if you're like me, you must have asked yourself, are all edges the same length on a tetrahedron? And the answer is no. They are if it was a regular tetrahedron. And then the problem would be a piece of cake. Wouldn't be hard at all if you knew that all the edges were the same. The only two edges that are the same are KJ and LM. Now, I gave this to you because you're one of the brightest geometry students I know. And this took me, I could not solve this in real time during my session. I didn't even know where to begin. I really didn't.
So I'm going to start off by stating the given, right?
I stared at this thing for 30 minutes visually, and then it hit me like a ton of bricks. Without writing anything down, without doing anything, I figured out how to do it strictly by looking at the picture. And the only two pieces of information you need are JK is equal to LM, and that each of the corners of that rhombus are midpoints of the edges. I'll give you a few minutes to look at it.
Okay. What I'm beginning to see
And don't worry about the
is that
proof. Just figure out how to do it. And then you can always get it into a two-column proof once you understand how you're going to prove it.
Did she understand how to do this?
No.
Ah.
No. I just explained.
It
took me an hour. It took me an hour to figure out the logic behind how to do it.
All I'm seeing is that they are creating triangles.
Okay. They're creating triangles. Well, the triangles are already there. Are you talking about JKL?
Oh, I see something.
Okay, what do you see?
I see that I don't know if this is correct.
Define the line segment.
There are no points, but I do know that EH, due to the definition of parallelogram, EH is congruent to FG, and I can go on from there.
You don't know it's a parallelogram. They don't tell you what it is. They don't tell you what it is.
No, you're right.
The question is, prove that that is something, so you cannot make any assumptions about that figure.
No, you're right.
The only assumptions you can make is that EF bisects line KL and bisects line JL. That's a clue. I'll give you one more clue. This should be enough for you to figure it out. What's that thing called?
A midsegment of a triangle.
Right. Go to town on that, because you know if that midsegment is 5, what's the base?
I see it now.
What's the base? 10, right?
I see it.
Okay, explain it to me.
Wait,
don't give me
the midsegment of the triangle. So it's going to have to be 1/2 of the length of the base. Okay. So that midsegment would have to be 5.
So which midsegment are we talking about?
We are talking about FG, right?
Okay, so you're saying
right now.
FG is what?
And then there's also EF. Then there's also EF.
Okay. So work me through your logic.
And there's also, so, splitting this into multiple triangles, I have EF is a midsegment, I have FG is a midsegment, and I have EH is a midsegment.
Okay.
And this splits them into similar triangles.
And there's one more. HG. HG has to be a midsegment.
Oh, yes. F, and then that unknown point.
Which unknown point? They're all labeled. E, F, G, H are the places where this shape intersects with the...
Oh, wait, it has to be... There's GH too.
Yeah.
Yeah.
You're on the right track. So tell me about EF. What's EF going to equal?
EF's going to equal half of JK, right?
Okay. And then tell me what FG is going to equal.
Half of LM. So therefore they must be congruent.
Exactly, because they tell us KJ is the same as LM, so that makes EF the same as FG. Now notice something very clever. If you look at EH, that's the midsegment of which triangle?
JM, or JLM.
Right. Whose base is LM. So EH is what?
Congruent.
Equal to half of LM.
And then I see it. GH is midsegment to MKJ, which is base is JK.
Right.
There we go.
It's got that same. In other words, these two edges are the bases of two different triangles, or I should say of four different triangles. You actually have four triangles that we're looking at here. It's just that you're not used to seeing JK be the base of two different triangles, and yet it is. So is LM.
I think at the end, Zach, we're going to put that on the non-multiple choice part of the final. That would have been like a 10-point proof.
This is one of the harder problems I've seen in a long time. I've seen some hard, like I said, geometry problems come in all flavors. You can get geometry problems that would cause a PhD problems. So it's not a question of trig being harder than geometry. In general, it might be. But every math discipline, including algebra, has problems that up the upper end of the spectrum are extremely difficult. You know, graduate school, math major difficult. And this is one of them. And the reason this gave me problems, and I'll tell you, is that I looked at it thinking it was a three-dimensional geometry problem. And I've always been a little weak at three-dimensional geometry. I understand your basic 3D solids and the formulas for their volume and their surface area. You haven't really got to that yet. You'll get to that next semester. But I understand that. It's just that when you look at complex 3D problems, they've always been hard for me, as opposed to two-dimensional geometry, which has been easy for me always. Well, when I looked at this as a 3D geometry problem, I couldn't solve it. I just couldn't, I didn't even know where to begin. But the moment I saw that EF was a midsegment of this two-dimensional triangle, I realized, aha, and FG is the midsegment also. And then I realized that those two dotted sides were the midsegments of a triangle that had that same base and this same base.
I feel like I certainly wouldn't have solved it for much longer if you hadn't given me that third hint.
That hint was big. In other words, but the hint is all the hint told you is that you're looking at midsegments, and then all of a sudden you knew that midsegments were half the base, and you went from there. So that's a big hint, but the real key to this problem is realizing that it's a two-dimensional geometry problem. It is not a three-dimensional geometry problem, despite what it looks like. I even looked up online the definition of tetrahedron because I wasn't sure if tetrahedron meant that these were all isosceles triangles, maybe, in which case KL would be the same as KJ. And of course, if that's true, the whole thing...
It doesn't even look like isosceles triangles.
Well, they do. It looks like a regular tetrahedron. But that's the point. A regular tetrahedron, all four triangles would be congruent.
What is a tetrahedron?
This shape. Call it a pyramid. Notice that it's got a triangular base and it's got three triangular sides. That's a tetrahedron. The problem is that K can be anywhere. It doesn't have to be over the center of the triangle at the base. It doesn't have to be a regular tetrahedron. A regular tetrahedron, K would be over the center, all three triangles would be congruent, and all three would be congruent with the base. But just a tetrahedron is just four triangular sides. And so you can kind of imagine if you moved K to the left and left everything else the same, it would no longer be situated over the center of the triangle at the base. And it would be kind of a lopsided tetrahedron. But more importantly, it would make all three edges different sizes, different lengths. So because I couldn't solve it, I assumed, well, maybe we're supposed to know that Km is equal to Lm based on the fact that it's called a tetrahedron. I looked it up, and no, that's not the case. The only thing we needed to know was that Jk was equal to Lm, and everything else follows from that. Doesn't even have to be a regular tetrahedron, although I suspect that it probably is. I'm not sure you could get Kj to be equal to Lm otherwise.
Do you have anything else?
No, I do not.
No, like more multiple choice stuff.
I have the page 2. Here, let me pull it up and you tell me if you've done this already. I didn't get to this with her, but maybe you didn't get to it at all. I don't know. Here's the rest of the review packet.
Well, I think that 12 is the easiest stuff ever.
Well, most
and
of
so
them
is 13.
are easy. Like I said, I was kind of shocked. The only thing I can see that might be tough is 16.
That's a perpendicular bisector. That's not tough because we learned about that. That was like the first instruction we learned.
On how to bisect, how to draw a perpendicular line. That was the way to draw a perpendicular line is by putting.
That was like the second or third construction we learned.
Right, I know it is. It's one of the basic ones. I just hadn't had a chance to read it yet, so I hadn't realized that it was that simple. 10, you don't have any problem with 10, right?
Give me a second. No, I know the equations for that.
Okay.
A line that will be unquestionably perpendicular to the line 4x minus 2 is negative 1 4x. Has to have a slope of negative 1 over 4x.
Right, and there's only one that has that, yeah.
Yes.
Okay.
And
12 I wanted to talk about since you said it was already so easy.
I know, but any more difficult. Like we had one on Wednesday about a transition where the figure could have either been rotated 180 degrees, either clockwise or counterclockwise, or it could have been reflected over the y-axis and then the x-axis.
Which is the same thing, yes.
Yeah.
Both of those processes are symmetrical with the origin.
But, rotated 180 degrees around the origin.
Right. And regardless of which way you rotate it, you end up with a figure that has been reflected over the x-axis and then the y-axis.
Yeah, I didn't read all my answers.
Figure that's symmetrical to the origin. That's important. Remember that. You haven't learned about
What
that.
happened was I didn't read all my answers to that.
Odd
So,
functions are symmetrical with the origin.
I didn't read all my answers to that question, so I just wrote down that it was just rotated around 180 degrees around the origin.
Mm-hmm.
When it could have been both. So I got that wrong.
Oh, he didn't count that, huh?
No.
He needed you to say that it was rotated about both axes?
No, he had an answer stating that both of them were correct.
I got you. 13, you know that one?
Yeah, that's ASA or D.
What is CB?
No, that's AAS.
Yeah, it is AAS. What is CBD? That's one I never heard. He made that one up. That's not any kind of proof to prove congruency.
That's called cannot be determined. Wait, no, it can't be determined.
Oh, I get you. Okay.
It can't be determined. CBD means can't be determined, and the answer is cannot be determined.
For this problem, 13?
Yeah.
Well, let's see. We have that angle equal to that angle. We have that angle equal to that angle. We have, therefore, A is equal to O. So we have all three angles are equal, and we have two sides are equal. That's congruent.
What?
Those two triangles are congruent.
Well, we can't say that by one of those methods. Because for A and C, it's
Why can't you use AAS? In other words, it's angle N, and then the two angles that make up C. So that would be angle, angle, side. Oh, and this one's angle, side, angle. But the thing is that when you know two angles, you know all three.
Yeah.
So you really have, you know they're similar, and then you know that one side's equal to another side. Ah, I see what you're saying. Hold on a minute. Are you kidding me? Let me look. I got to look at the answers before I give it any more thought. It is cannot be determined.
Correct. No, it is congruent. They are congruent.
Well,
because once you fill the other angles in.
Because we can't prove it using one of those four?
No, it is correct. No, it's AAS.
Well, look at the answer at the bottom of the page. It says E for 13 on the answer key. 13 says E.
Well, that's stupid because we can prove them to. No, you're right because the
Well, let's look at this a second.
No, we can't at all because we may know the like let's say N is 60 degrees.
No, you're
This is hypothetical. This is hypothetical. Let's say N is 60 degrees, C is 90 degrees, and A is 30 degrees. And then H is 60 degrees, C is 30 degrees, and O is 90 degrees. See, that doesn't work. Oh, no, sorry. C is 90 degrees, and O is 30 degrees. See, that doesn't work out because the sides we have aren't on the corresponding sides.
Exactly. In other words, this is not CPTC because those are not corresponding sides of the two similar triangles. If I rotated this triangle, HCO, the one on the right, if I were to rotate it and put that angle on top of that angle, then notice that the side they're saying is the same. That's not the opposite side of that angle in this triangle, and it is the opposite side of the angle in the triangle on the left. So AC is not the corresponding side to CH. It's the corresponding side to CO. Yeah. Now, we do know the triangles are similar because we can prove that they have three angles that are the same.
Well, can't we already prove that they're... No, we can't.
No, that's a really interesting, this is a really interesting problem. I would have got this wrong. I thought that they were congruent. I just
we can prove that they are similar, though.
I failed to notice that they weren't giving us the corresponding side was being equal. Yeah, and that matters. In other words, here, I can draw a picture of one really good. I'll show you. Here, clearly, they are not congruent.
But they're similar, most likely.
They're similar. If I say
those two lines are parallel.
That,
those two lines.
Then I know that has to be equal to that. But if this was a 3, 4, 5 triangle, this could be an
8, 6, 10.
Yeah, I was trying to figure out something that had the same side.
That looks like it'd be about double.
Let's make this a 6, 8, 10.
Okay.
And then I would want this to be 10. No, I can't think of an example. We had a problem similar to this once upon a time. And it was very, very similar. Is that they looked congruent because they had two sides that were the same. But that doesn't prove congruency. It's got to be the corresponding sides are the same. And clearly that 10 is not the same side as this 10. This 10
that could be the same, and then everything else would just be a really weird number.
Right. Right. But the key when you're proving it is you have to have a hash mark there and a hash mark there. Merely means they're of equal length, but it doesn't mean that they're the corresponding sides of those two triangles. And the way to really tell that is that the one on the left is opposite that angle that we know is the same angle as up here on the right, but the 10 on the right is not opposite that angle.
You know what also almost screwed me up? The fact that if I had gone off of instinct, I would have gotten this question wrong. If I hadn't taken time to look at it, I would have put AAS and then just moved on.
Me too. Absolutely. I would have done the same thing. This is a very tricky question. Very tricky question. Take this tick mark over here on the right and put it on CO. Now they are the same.
Yep.
By AAS.
And then we also know that it's isosceles meaning, but yeah.
Well, we don't know it's isosceles, but it doesn't have.
Well, if we know that, oh, never mind.
Okay.
Oh, never mind. I thought you meant you weren't gonna just take it. You're gonna add a new one.
Yeah. Well, now I have a little more respect for some of these questions. They're not quite as easy as I thought they were. Let me take a look at 14.
Well, this is easy. I got this one correct on the practice final because I drew it out.
All right. Won't look any further then.
Wait. Yeah, no, that'd have to be go back up to it. That'd have to be a since they're both midpoints, they'd have to be a midsegment.
Okay. That I was going to say the only way I would know how to answer it is also to draw it out. In other words, if I have triangle.
Oh no, I didn't even need to draw it out.
E, M, T, E, M.
I didn't even need to draw it out.
X is the midpoint of TM, Y is the midpoint of ET, and XY has to be a midsegment, yes.
Hey, by the way, isn't a triangle made of midsegments also dilated by 1/2?
Yes. But there's other things when you talk about dilation. It's dilation off of a point. In other words, as long as that's the point that we're dilating off of, yeah, then the little triangle is a half dilation of the big triangle.
No, but I mean, think about it. If you took the midpoint of EM, which is Z, you'd still be making a half-scale triangle. Because you're taking half the points and making a triangle out of it.
Right.
Therefore, the points are half as long, meaning it's all a dilation by 2. It's dilated by 1/2.
Right. Okay, yeah. The next one looks interesting.
Which one is that?
So
which of the following is a reflection across
minus 2 comma 1 that you're reflecting across this line x equal 3.
So then you'd get, so that'd be 5 x values. You'd get you get 8,
Okay.
and then 1. So let's see.
Not 1. Oh, yes, 1. Excuse me. No, absolutely. Because a reflection across the x-axis does not affect the y-coordinate. It only affects the x-coordinate. I didn't mean the x-axis. I meant the line x equal 3.
Yeah.
Or if you were reflecting over the y-axis, it does not affect the y-coordinate.
Mm-hmm.
Just like reflections over the x-axis.
It doesn't affect the x-coordinate.
No. If you reflect over the x-axis, it does not reflect the x-coordinate.
Oh, no, you're right.
In other words, if I took this 8, 1 and reflected it over the x-axis, it turns into 8 comma minus 1, right? So the x point is not affected by a reflection over the x-axis. And the y-coordinate is not affected by a reflection over a vertical line, whether it's the x-axis, or, excuse me, whether it's the y-axis or the line x equal 3, they're both vertical lines. And so when I reflect about either one of them, it does not affect the y-coordinate. All right, let me just take a look at the rest of these. I haven't looked at these yet. All right, here we go. Here's a question on, just a second, let me blow this up. 17.
It'd be 2x plus 3 and then 2y. Sure, that's E. $17 is E.
Yeah, hold on. For some reason, I'm having a hard time figuring out. Oh, I see. Okay, the point xy gets dilated by a scale factor of 2 and translated 3 units. So actually, both the x and the y are dilated.
Mm-hmm.
So we get 2x and 2y, but then because it's translated to the right, that affects only the x-coordinate.
Yep, so 2x plus 3 and then 2y.
Yeah. Yeah. That's actually a little tricky, though. Yeah.
When constructing a line parallel to a given line, you will be copying an angle, right?
I would say you're constructing a perpendicular twice.
Well, yes, but
You see why?
It doesn't say it twice.
Well, that's true, but in other words, if I have a line and I want to draw a line parallel to that, well, I know how to construct a perpendicular to it, and then if I construct a perpendicular to that, I end up with a line that's parallel to that.
Yes.
Now, the question is, could we get it? We certainly couldn't do it by copying a segment. That's going to give us length only. I don't think we could do it by copying an angle.
Well, how we learned it
was what we could. We know, well, you'd have to, copying an angle, first you'd have to construct a perpendicular. And then you could copy that angle and make sure.
No, actually we didn't. What we did is we just made a transversal, or what was going to be a transversal. And then we copied the angle, found our point, and then just used that. But because I don't remember that, I just construct 2 perpendiculars.
I think that's the answer.
But his answer would be copying.
There's copying an angle. Wow. Hold on a second.
18 is B. Yeah, 18 is B.
Well, you tell me, how do you do it?
I don't exactly
If a
remember.
horizontal line, how do you construct a parallel line to that? By copying an angle.
I don't remember. We learned about this a while ago, but I wasn't exactly paying attention. So how I learned to do it was I learned to just construct a perpendicular twice, and that works out for me.
Yeah,
But
me too.
for him, I knew that he taught it by copying an angle. Therefore, I knew that that would be the right answer.
Okay, good. So if we have an angle here, we'll call theta, and I want to copy that angle.
But when we're making perpendiculars, we always
have compass on 2 points that are equal, and then I put my needle there, and I draw an arc that's at least half. And I put my needle there, and I draw an arc that's at least half. And now I have bisected that angle. No, there's a different way.
Oh, I know how. I think I figured out how.
Okay.
So what we do is we make an angle.
Okay, like this. Okay.
We copy an angle.
How do you copy an angle? I'm not sure I know how to copy an angle.
So what you do?
You put it on there. You run a.
What you do? No. How you do it is you make a mark. Is you make an arc along, and then you retrace the arc up there on that upper point, and then you're going to mark the distance between the transversal and that flat line that you're making parallel.
A compass
and then you
is really a measuring device. That's all it is. It's a device for measuring linear length. Okay? Think of it as that always. Even though it makes angles and stuff, it doesn't really make angles. It merely copies lengths. So if I wanted to copy angle theta, I would make the arc from there to there and from there to there. And I would go down here and I guess I would have to draw another line, wouldn't I?
So how we learned to copy an angle was first we went at the base of by copying an angle we already had an angle preset. For angle copying, we had an angle preset, and we were using that to construct triangles.
Tell me how to do it using the compass.
Yes, using the compass. So we had angle BAC, then we put an arc through it, and then
where do you?
And then we had a line. Okay.
Tell me where to put the needle and where to put the pencil.
Okay, you put the needle at A.
Okay.
And then you make an arc anywhere. It doesn't need to be through B or C. It just needs to be anywhere.
Okay.
And then you already need to have a line below that is showing where you start the copying of the angle. Then you duplicate that arc from the same distance across. And then you measure the distance from where the arc intersects both sides of the angle. So like if it went through B and C,
it's always going to be the same distance. In other words, from that point to that point is always going to be the same distance. So
no, what you're doing is you're measuring. Let's say it went through points B and C. You measure the distance between points B and C. Place your needle on where the arc intersected that bottom line.
Okay.
And then you mark that.
Put your needle and there and measure this distance here.
Yeah.
And then
and then you just mark that on the line.
There, make that same distance measure, make your mark.
And then draw a line.
Now you've duplicated.
So how do you do it? So then
how do you do it for 100? How do you do it? I see how you do it for a 180-degree angle.
No, and then to make parallel lines, you just copy the line again, except use the transversal as your flat line.
Hold on.
And then copy that previous angle and make your arcs.
I'm giving you his solution as to how you can make a parallel line by copying an angle. Okay? So what we want is a line that we're going to duplicate this 180-degree angle, right?
Mm-hmm.
So, we just use the bottom of it. In other words, we draw the trace all the way around. Okay? Now, I want the distance from here to here. Still not sure how to do it. I don't know how to do it in one step by just copying that 180-degree angle. Can't quite picture how to do it. And I understand now how to create an angle theta, how to copy that. But that merely creates an angle. It doesn't create, in other words, I don't need my other line to be parallel. When I'm copying theta, this line doesn't have to be parallel to that line at all.
Can I tell you something?
Sure.
I'm going to explain this to you. You know how you copy the angle, right?
Uh-huh.
You keep the transversal going, and what he gives us is a point. He gives us a point. So this time you use the transversal as your straight line. You copy the same distance as you did before, like the same distance away from the point onto that line, and then you mark the distance between the arc intersects.
Okay, I got you.
And then you can create a parallel line from that.
Right. All right, well that one's pretty tricky. Some of these are a little tricky, which makes me, Yansack isn't disappointing after all. When I saw the first 9 questions, I said to myself and my student, boy, this does not look like the typical degree of difficulty for Yansack. Usually he goes a little harder than most. All right.
You can't give all questions. Sometimes these questions are hard, but for people who haven't studied.
Right, for
these
sure.
These questions just seem easy to you because you know how to do them and I know how to do them, but a lot of people in my class don't actually know how to do them.
Really?
Yeah, because they're not. There are a lot of people who shouldn't have gone.
Shouldn't be in honors. Yeah.
Yeah.
Yeah, no, I ran into a couple of them last year, and they dropped out of honors. I didn't run into them until about mid-year, and that's when they dropped out of honors.
Not just because, well, that's when they have to. That's the only opportunity they have.
Oh, is it? Oh, okay. Yeah.
You can't switch unless it's like the beginning of the semester.
Okay.
But we have some, it's not just the fact of not turning homework in. It's that they get bad scores on tests. That's why they should.
For sure. No, anybody can turn homework in. So all you got to do is hire a tutor, and you can get your homework 100% of the time. But being able to learn that knowledge and then translate it and use it on tests, that's the secret. So just turning homework in really isn't a sign of anything. The teacher doesn't even know if the person turning it in is the one that did it. No guarantee, right?
Yep.
So, all right. Bolton, I am going to let you go. Unless you have any questions you want to ask about geometry in general. Your test is tomorrow? Isn't it a 2-part test? I thought he gave us tests in 2 parts.
Yes.
Over 2 days.
I had my non-multiple choice part Friday. That's worth 1/4 of the finals grade. So worth 5% of our grade. And then I have this tomorrow. I have the non-multiple choice, which is 75 questions, and worth 15% of our grade.
Friday? He makes you go to school on Friday? Isn't everybody off for the holidays by then?
What? He made us school.
No, he has school on.
No, I'm talking about tomorrow, Wednesday.
Oh, Wednesday is the second part.
Last Friday we did the non-multiple choice section. Then tomorrow we're doing the multiple choice section.
Oh, okay. Well, you should certainly do good on the multiple choice section.
I'm not going to jinx myself, but I really hope I do.
Yeah. No, I think you will. You understand this stuff pretty good, Bolton.
But like Yansack, he makes his tests too long.
Yeah.
Unlike me, I always make some stupid screw up. Like for transformations, I forgot to label the points of the new figure. Like the first figure was triangle ABC. I didn't label it triangle A apostrophe B apostrophe C apostrophe.
I'm surprised at that because you're better at that than anybody else in using the names of the triangles to find the corresponding sides, for one thing.
It's not that. It's just labeling them in transformations. I make stupid mistakes like this all the time.
Yeah, well, which makes you slow down, and then speed does become a factor for you in taking the test.
Oh, no, it's not that it screws me up speed-wise, but...
Well, the solution to making silly mistakes is to slow down. Now, whether that would allow you to finish the test fully in time, maybe not. In other words, you might have to go at a certain speed and live with whatever arithmetic errors you might make.
I don't know how I remember this, but in 5th grade once, I aced every single problem on a test, except for this one really easy problem, which I didn't even see.
Yeah.
And I would have gotten it correct, but I just didn't notice it.
I mean, if somebody would have bet me money that I couldn't get all 8 of these right, I would have bet a lot of money that I could get them all right first time through in a half an hour. And I would have gotten 13 wrong. That's the only one I would have gotten wrong, but I would have gotten 13 wrong.
Yeah.
All right, Bolton, you have a good test. Good luck on your test, and have good holidays, and I'll talk to you after the Christmas break. I'll check in with your dad as to when you guys want to start back up again.
Okay.
All right?
Bye.
All right. Have a good one. Bye-bye.
Bye.